NCBM 0324, Section 1.1, Order of Operations, Part 4. So we're slowly building our experience and our knowledge of these order of operations scenarios. And let's see some that look a little bit different. Part K, we're still evaluating the expression, so our answers are going to be a value, a number. And in Part K, we have 6 squared minus 3 times the square root of 25 divided by the square root of 6 squared plus 13. So I have a lot going on, this new operation of square root, but we're still going to follow the same order, right? We're still going to deal with parentheses, and then exponents, multiplication, division, addition, subtraction. So in this problem, I don't quite see any parentheses, except looking at the denominator, looking at that bottom, I have a square root. So this is telling me the inside value is going to be taken a square root of. But inside, I have this addition in here. So that square root, because it goes over both the 6 squared and the 13, this itself is going to act like parentheses. So in my first step, I'm going to deal with this inside of my root in my denominator first. Let's simplify that down and then deal with everything else. So then I'm going to copy my 6 squared. And you'll notice in my numerator, in case you're wondering, the square root in this part, it's a single number already. So I don't have to simplify that more. I want to get this square root to look more like the numerator one. So that's why we're working on it first. Okay, so square root on the bottom. 6 squared, that's 36, plus the 13. And you might be wondering, and it's mighty tempting, to try to do the following. I see a square root, I see that 6 squared, and then I try to simplify it. And then I would get something like 6 plus the square root of 13. Well, that is very tempting, and might make things seem a little bit simpler. It's actually mathematically incorrect. When I take the square root of something, and I have an addition or a subtraction, that square root does not pass through those operations. These are not the same. They are not equal to each other. So that's why we want to get the single value inside, and then we can take a square root. Okay, so tempting, but don't fall into that trap. All right, so my denominator, I now have the square root of 36 plus 13. Again, this is like parentheses, so I'm simplifying that denominator first, the inside of the square root of the denominator. And we have 36 plus 13, which gives me 49. And now I can simplify my roots here. In fact, both of these, we can do this at the same time, are now a single value inside, right? So I can apply my square root idea. And in my numerator, square root of 25. So what number multiplied by itself gives me 25? Well, that number is 5. Then in my denominator, square root of 49. What number multiplied by itself gives me 49? Well, that's simply a 7. So we dealt with the radical first, the square root first. We simplified that inner part, then worked our way to the outside parts. Let's keep going. I have an exponent, so 6 squared is 36, there we go, minus 3 times 5, divided by the 7. So now we're doing multiplication in my numerator before I can do the subtraction. I'm simplifying each part here, and then I'll do that division, right? Each part, I mean top and the bottom. So I have 36 minus 15. That's my next operation I'm going to follow. And 36 minus 15 is 21. Divided by 7 gives me a final answer of 3. Right? So all of those roots that we started with in the beginning, all those operations boil down to a simple 3. So evaluating expressions, right? We're simplifying this, we're applying these operations to get a nicer value, something a little bit more manageable. I'm going to skip now to example N. And in example N, we have a special form of some values, and you're going to see where we use this in a future section, but for now, we're just going to practice how to evaluate it. So I'm going to, again, go to part N here. We have a negative of a -4 minus the square root of -4 squared minus 4 times -1 times -3, all of this divided by 2 times -1. I see a lot of parentheses, right? Glancing at this problem, thinking about my PEMDAS, I see parentheses. But notice inside the parentheses, we have single values. So really no simplifying of the parentheses here. I do see an exponent. This -4 is squared. And in fact, the parentheses help us keep track of these negative values. Remember, in a previous example, we had a negative of a negative. So that's our parentheses kind of helping us make sure that we recognize there are 2 negatives here. And then in this parentheses of the exponent case, we're showing that the -4 is the value being squared, right? If I say something like this, that's a different meaning because now I'm going to do the square value first and then the minus, right? But when it's inside, that's telling me I'm going to do the same number multiplied by itself. As opposed to saying up top here, the 4 and the 4 are being multiplied and the minus gets applied after, right? These mean different things. So that's how the parentheses can help us. And why whenever you're dealing with negatives, it might be a good idea to hold them inside of these parentheses. All right, so let's go through the problem now. I'm going to start simplifying here. All right, maybe I'll keep track of a minus there. I'll do my exponent value first. So again, -4 is being squared. So that's -4 times -4. Well, that gives me a positive number, and the positive number is 16. So I have a 16. Let's just copy the rest of these. You might be more comfortable at this point, so maybe we can start doing multiple steps together. Okay, so I did my exponents. Remember that square root is acting like parentheses, so I'm going to deal with this inside before I take the square root. But I noticed in front I have a minus and a minus, so maybe I'll change this to a 4, a nice positive 4. If we don't feel comfortable with that, keep it there and then fill it in later. But I think we're ready to make that a positive 4. Then inside I'm going to have 16. And I have all this multiplication. So I have a minus times a negative times a negative. And that's like 3 negatives. So I know my answer is going to come out to be negative. And then I can deal with the values. 4 times 1 is 4. And then 4 times 3 is 12. So we're getting there. We're slowly breaking this down. Okay, so I have my positive 4 from that simplification. Still dealing with my inside here. And I can do the subtraction. This is a 16 minus 12. That gives me 4. Notice I've just dragged my denominator along. I could have maybe in one of these steps combined that multiplication. Or I could have just kept it going, whatever I feel comfortable with. And then I could say now, what is the square root of 4? Well, the square root of 4, what number multiplied by itself gives me 4, is 2. So we're simplifying. We're going with that order of operations. So I guess I can do the bottom now. That is a multiplication before I do the subtraction. And then I'll do the bigger division. 2 times -1 is a -2. Let's go at the top now. We have 4 minus 2 divided by -2. 4 minus 2 is 2 divided by -2. And that gives me a -1 as my final answer. So they can get a little complicated, but you take it step by step, keeping track of the signs, right? That's so important in any of our calculations that we make. Make sure you have your signs correct, double check them. Take it step by step if you need to. If you feel more comfortable, you can start to combine some of these operations together.